Okay, so to begin, we're going to work on exam 1, question number 1. So question number 1, it asks, for the following data represent exam scores in a statistics class taught using traditional lecture and a class taught using a flipped classroom. The flipped classroom is one where the content is delivered via video and watched at home, while class time is used for homework and activities. So we're just going to do the traditional exam scores. So the numbers for that are 70, 69, 79, 67, 85, 78, 56, 81, 80, and 71. So these are the numbers, these are the exam scores, as mentioned before, that are in the traditional classroom. So what we want to do is we want to compare the mean, the median, the mode, variance, and standard deviation. So like I said, we're just going to do the traditional scores because it's so many. So what we're going to do is, in order to find the mean, we're just going to sum up all of these numbers and then divide them by that specific amount of scores, or the total amount of scores. So just do add them, which is equal to that would be equal to, let's do it right here, plus 79 plus 57 plus 85 plus 78 plus 56 plus 81 plus 80 plus 71. So that would be equal to 736. And there are 1, 2, 3, 4, 5, 6, 7. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 numbers in total, or 10 scores in total. So we're going to divide 736 divided by 10, which is equal to 73.6. So this is the mean right here. So label that as the mean. So now we want to find the standard deviation. I'm sorry, the variance first. So we're going to find the variance. So in order to find the variance, we're going to erase off of that. And in order to find the variance, remember, we're going to have to utilize the mean. So that's the mean. So the formula for finding variance is basically the sum of means, wait, right? I'm sorry. Sum of x minus the mean. So whatever number you have minus the mean squared over the number of test scores that we have here. So what we would do is basically, so for the first one, be 70 minus 73.6. And you would add that to 69 minus 73.6. So when you're adding them, you want to square each one. Square. And basically do that across the board. So once you do that across the board, you get a total of 693.6, and then you want to divide that, once again, divide that by the number of scores that you have. So then that comes out to, I'm sorry, not 69.3.6 or 693.6. It'd be 693.01. So that equals 69.301. So this is your variance, right? So now that you have variance, you want to find standard deviation, which basically tells you how far or the amount of space each test score or each student is from one another. So basically variance just tells you the amount of variety of scores that there are from the mean, so how far like each other test score is from the mean. And the standard deviation basically tells you the amount of space in between each test score once you go across the board. So in order to find standard deviation out of the variance, all you have to do is find the square root of the variance. 69.301, find the square root of that, and it comes out to 8.32. So 8.32, so that's relatively high. So you can see it in the test scores. That basically just shows you that there's a lot of space in between each test score, and they're not very close together. So that could be a good thing, it could be a bad thing, depending on what exactly you're looking for when testing. So now we're going to go to, let's make sure you can see. So now we're going to go to okay, so now what we're going to do is we're going to do question 1, part B. So for this one, it basically asks us to find the relative frequency and the cumulative frequency of a range of exam scores in the classroom. So here are the range scores, or the range of scores that are listed on the question. So 50 to 59.99, 60 to 69.99, 70 to 79.99, and 80 until 89.99. So this is the number of students who received each test score. So for 50 to 59.99, you have 1 student, 60 to 69.99, 2 students, 70 to 79.99, 4 students, and 80 to 89.99. So what we want to do is we're going to find the relative frequency. So basically the percentage of students, or percentage of the amount of times this test score occurred, or a student basically received this test score in this range. So in order to do so, what you want to do is, basically what you're going to do is you're going to do the amount of student, or the amount of times the student, or the amount of students that achieved this test score. You're going to do that, divide that by the total number of students. So in this case, it's 10. Once you add all these up, the number is 10. So 1 divided by 10 equals 0.1. Then 2 divided by 10 equals 0.2. 4 divided by 10 equals 0.4. And then 3 divided by 10 equals 0.3. So one thing to basically like check your work is all these relative frequencies should add up to 1 or 100%. And then what we want to do is Next, we want to find cumulative frequency. So cumulative frequency is basically um, just adding up each relative frequency. Um, just show like the correlation or relationship between each relative frequency and how they relate to one another. So in order to do that, it's simple. So all you're going to do is start off with the first relative frequency, 0.1. You add that one to the next relative frequency, so it'll be 0.3. Add that one to the next one, 0.4, so now it's 0.7. Then, of course, add that to the next one, and once again, it should equal up to 1 or 100%. So that is that. So moving forward, the next question, or the part C of this, asks what percent of students have a score less than 80. So basically, this is what this basically tells you, just by looking at what we did here with the frequency. So it asks what percent of students has a test score less than 80. So what you would do is just look at the test scores less than 80, and you go to your relative frequency and you add them all up. So 0.4 plus 0.2 plus 0.1 equals 0.7. So the answer to that would be 70% of the students receive a test score of less than 80. So then the next part of that would be approximate the mean and standard deviation of each exam score. So in order to do that, it's relatively simple. So you want to find the mean of each test score and standard deviation. As mentioned before, it's basically the same steps. So all you really want to do is, in this case, you just want to take the midpoint. So the midpoint of each test score will be whatever point or whatever number that falls in between the beginning and the end. So in this case, it would be 55. In this case, 65, 75, 85. So what you want to do from there is the same, relatively the same steps. Although you want to use the frequencies that we used before, and you want to just take the midpoint, multiply it by the frequency, and add it 5 times 2, and then 75 plus 20 times 4, and etc. Then you want to divide that, of course, by the total number of students we have, so divide by 10. So once you do that, you should come up with 740 divided by 10, which equals 74. So now that you have the mean, the standard deviation is simple. So you basically just take the mean, and you do the same steps as you would do before any other standard deviation, and you would just go just take the midpoint, all over 10. So that you should come up with. Erase this real quick. So I don't forget. So with that. 1 plus 81 plus 1 plus 121. So equals 564 divided by 10 equals 56.4. And you find the square root of that. Comes out to 7.5. So that's basically how you find the standard deviation of a range of scores. So basically what this argues is, and the best way to look at it and to like find out if a probability is unusual is to equate it to 0.05. So in this case it's less than 0.05, so it's kind of unusual. So like considering that the population is 45% Hispanic and only 2 out of 12 are selected, it's kind of uneven. Kind of shows that they're kind of unrepresented in this case because less than 5%. So that's basically what this tells you. Moving forward, we're going to do number 2. So number 2 is actually different from this as well. So basically what number 2 as that according to Miratrix.com, traffic fatalities occur at the rate of 1.32 fatal accidents per 100 million miles. Find the probability that during the next 100 million vehicle miles there will be, first to start off, exactly 0 fatal accidents. So this one's pretty simple. So how you want to set it up is you want to use the formula. So the formula with a rate, or like an average rate, is Px, so the probability, the given probability, whatever they want you to find, is equal to lambda, which is the rate, and which is the rate, and in this case, of course, it's 1.32. To x, the x power, which is of course the probability, the given probability we want you to find, over x factorial times e to negative lambda. So in this case, they want you to find 0 fatalities that will happen at the rate of 1.32 per 100 million miles, and it would be p 0, of course, 0 fatalities equals 1.32 0 over 0 factorial 2. So this is basically how you would set it up. And once you do all the math and put everything together, the number that you should get would be 0.2671. So basically 26%, 26 to 28%, if you want to round up. That's the chance that there will be 0 fatalities at the rate of 1.32 per 100 million miles. So you can do that for 1, 2, 3, 4 fatalities, etc. moving forward. So to continue, okay, so next what we're going to do is we're going to find probabilities. So we're going to do a simple probability problem. So in order to do that, we're going to do, let's see here, we're going to do number 2, part A. So part 2, part A says a standard deck of cards contains 52 cards. One card is randomly selected from the deck. What is the probability of randomly selecting a heart or club from a deck of cards? So basically, as it states before, we have 52 cards. And then we have hearts, we have clubs. So let's just think that those are the only type of cards we have, and it's a 50-50 chance we can get both. So in that case, we have 26 26 hearts and 26 clubs. So in that case, when you're looking at probability and you're looking at probability like this, you want to split that probability in half. So like I said, it's a 50-50 chance that we can randomly select each of them. So in order to find out, so like I said, there's 26 of each. So that means that there's there's a chance we can pick 13 cards of hearts and a chance that we can pick 13 cards of clubs. So when you want to do that, you want to put the total amount of cards that you can pick below the possibilities. Then you want to add them. There you go. So in this case, 26 over 52 over 2 equals 0.5. So as mentioned before, it's a 50-50 chance that you can pick a heart or a club. So moving forward, we're going to move to a more like complex example. So part B says about 5% of the population of a large country is math phobic. If 2 people are randomly selected, what is the probability both are math phobic? What is the probability at least one is math phobic? So in order to find that, it gives us the percentages. So you have 5% are math phobic, so they fear math like me. And then if 2 people are randomly selected, what is the chance or probability that both are math phobic? So you have 2. So basically what you want to do is you just multiply the probabilities of 2 math phobic individuals. So that comes out to 0.025. So that's the probability that 2 will be selected. So moving forward, it asks what is the probability that at least 1 is math phobic. So in order to do that, you basically just subtract 1 minus the probability of like everybody else. So 0.95, and then you multiply that, of course, by another. This is the probability of someone who isn't math phobic. So 1 minus 9.5, so that's 9.5, which equals 0.9975. So this is basically the probability that at least one person is math phobic. Basically what you do is you subtract the probability that two non-math phobic people are selected, and you subtract one, so the 100% minus that, basically. And then moving forward, 3 says because of a mistake in packaging, a case of 12 bottles of red wine contained 5 Merlot and 7 Cabernet, each without labels. All the bottles look alike and have an equal probability of being chosen. 3 bottles are randomly selected. So, question 3, part A says, what is the probability that all 3 of the bottles chosen are Merlot? So, the best way to think about this is like the rolling of dice. So you're rolling the dice 3 times. So you want to basically think, okay, instead of rolling dice, that's a bad example. So just thinking about this example at hand, when you're selecting 3 bottles of wine, right? So the first time you pick, right, what's the probability that you have 5 bottles of Merlot and 12 bottles total of wine? The first time, it's a 100% chance. Okay, 5 out of 12, I got my Merlot. Boom. Next, since there's one gone, there's a less chance, but there's less bottles. So the next time, it is 4 over 11. So now, since we have four bottles of Merlot left and 11 bottles total of wine. So the third time you choose, same thing, it goes down one more time. 3 bottles left, and there's 10 bottles, or 3 bottles of Merlot left, 10 bottles total of wine. So basically what you're going to do is just multiply all of these. So it comes out to 1 over 22, which equals 0.045. So there's a 0.5% chance, or 5% chance, sorry, roughly, that you will select all 3 bottles of Merlot. You go 3 times, or if you pick 3 times. So next question asks, what's the probability that exactly 2 bottles of Merlot are chosen? So you want to set this one up a little bit differently. So in order to set this one up, you want to start off with, so you have 5 bottles of Merlot. So it's 5 possibilities that you could pick Merlot, right? And C, 2. So 2, once again, is exactly 2. So the chances that you'll pick 5 bottles of Merlot, or pick 2 of the 5 bottles of Merlot, basically, in 3 different chances. So what you want to do then, you want to multiply that by the opposite probability. So of course you have 7 bottles of Cabernet, and if you're picking exactly 2 bottles of Merlot, then you can only pick 1 bottle of Cabernet. So you want to divide that by the overall number of chances as well as the bottles. So let's see, you have 12 bottles, and you have 3 choices, or you have 3 times 3 chances to choose, or 3 chances to pick. So how you want to do this is basically want to rearrange this as, which is 5 times 4, which is basically 5 factorial, and then do over 2 times 1, which is 2 factorial. Multiply that by 7 over 1 and 3 times 2 times 1 over 12 times 11 times 10. So notice how I said 5 factorial, but there's 2 cases, so 5 times 4, 2 times 1, it's only 1 case, so you do 7 over 1. This one you have 3 cases, 3 times 2 times 1, 12 times 11 times 10. So this all equals to 7 over 22, which ultimately equals 0.3182. So basically, it is a 30% chance, or 32% chance that you'll pick exactly 2 bottles of Merlot. Okay, so for number 4 of exam 2, the question basically says the length of human pregnancies is approximately normally distributed with mean mu equals 266 days and standard deviation 16 days. So the question basically asks, what is the probability a randomly selected pregnancy lasts less than 260 days? So this is basically a case of random sample probability. So in this case, they already give you the mean and the standard deviation. All you have to do is find the probability. So the best way to write this would be P is X is less than 260, right? So in this case, when you look at a probability random sample, you have to involve the z-score. So the z-score is basically just the proportion, the percentage of that probability, basically, but just for a specific sample, because in the z-score you're looking at a normal distribution. So the normal distribution, of course, you have like the mean, the standard deviation, etc. But it does not necessarily tell you like the percentage, or it doesn't tell you like exactly the percentage of what you're looking for. It just gives you different intervals or different deviations of that normal curve. So the z-score basically allows you to transfer or transcribe that deviation or that specific point on a normal distribution and into a percentage of that normal distribution. So what you want to do is z, of course, is less than, and then you want to do probability, of course, minus the random sample. And then you will divide that over the standard deviation. So what you would get from this is, once you do all the math, it's P, Z equals, or Z is less than negative 38, or negative 0.38. And so when you get this number, you want to basically look at a z-score list, and then it'll give you the percentage. So in this case, when you look at the list, 0.38 transcribes into 0.3520. So this basically just tells you that 35% of the probability, it's a 35% chance, that a randomly selected pregnancy will last less than 260 days. So once again, this probability is based on looking at the overall normal distribution of pregnancies over a certain amount of time, and looking at it, and basically you're just doing math to find the probability that this amount of pregnancies will land less than 260 days. So, and the standard deviation is basically used, once again, to just like tell you the different spaces in between each number or each day. So that's why that's important as well. So number 5, it says, according to a study done by Wakefield Research, the proportion of Americans who can order a meal in a foreign language is 0.47 or 47%. So this one is similar to the one we did before with the jury, as it involves an average percentage of the population, or proportion basically, but instead this one involves a random sample as well. So you want to basically do it similar. In my opinion, you're basically just putting the two kind of together in a sense, but you want to do it. In this case, you have to use a different formula. So in this case, the formula we're going to use is NP times 1 minus P. So as it says before, it gives you the sample size. The sample size is 200, and it gives you the proportion. So you want to do that. So basically 1 minus 7 is 0.53. And basically this just comes out to 49.82. So this, you want to just basically make this greater than, you're going to find out if it's greater than 10. Basically find out if it's normal. So if it's above 10, then it's normal. If it's less than 10, it's unusual. You can't really use it. The correlation doesn't necessarily work. So with this, moving forward, now you have the proportion, the mean, the standard deviation. So what we want to do now is we want to find the sample, the proportion standard deviation, or the sample standard deviation. So in order to do that, I'm going to use the formula minus P over N. So we have all that already, so it's 0.47 times 0.53 over 200. So once you do all the math, it comes out to 0.035. So this is the proportion standard deviation. So it's different from the standard deviation, the sample standard deviation that we had before. This one basically explains the proportion of 0.47 and the standard deviation. Okay, so for quiz 3, it basically gives us a scenario where there is a Burger King drive-through, and there is a rate of 20 cars that pass through it every hour between the times of 12 noon and 1 o'clock p.m. A random sample of 41-hour time periods between noon and 1 p.m. is selected, and has 22.1 as the mean number of cars arriving. So basically, in this case, we're going to select a sample away from, normal time as mentioned before. A random sample is taken separately, which involves 41-hour time periods between noon and 1 p.m. So B basically asks, what is the mean and standard deviation of sampling distribution of X, assuming that mu equals 20 and standard deviation equals the square root of 20. So in this case, it's already given to us. The mean is 20 because mu equals 20. So they already gave us the mean there. And then for this case, we want to find the sampling standard deviation. So it's different from the standard deviation that's given to us, which is the square root of 20. But we could use that standard deviation in order to find the sampling standard deviation. So in order to do so, we're going to write it out as X equals standard deviation over square root of n equals, once again, the standard deviation in this case is 20, it's square root of 20 over the 41-hour period. So that's, that's in 41-hour periods. So square root of 40. So when you do that, it comes out to square root of 1/2, which equals 0.707. So this basically says that 70% of basically the standard deviation of the sample is roughly 0.70. Not 70%, I don't know why I said that, but it's roughly 0.707, meaning that's like the amount of time each car comes in, or between each average time each car comes in. So then C asks, what is the probability that a simple random sample of 41-hour time periods results in a mean of at least 22.1? Is this unusual? So it's a little bit similar to what we did before when we're just looking at probabilities that involve z-score. And in this case, we're going to do roughly the same thing. Instead, we're going to involve the standard deviation and the overall number of periods used. So in order to do so, Z, once again, and then the mean is 22.1 minus so we're going to do the standard deviation, the population standard deviation over, which is basically the simplest standard deviation. So that comes out to over 0.707, right? So this basically turns into 2.97. Do the math all the way through. So the z-score 2.97 transfers over to 0.9985. But you want to find out less than the z-score in this case. So you do 1 minus 0.9985, which turns into 0.0011.